Take a look at this huge cylindrical shaped structure. This stores enough thermal energy to power a small village in southern Finland. The world is generating more renewable energy than ever before, but there's a problem almost no one talks about. Solar panels don't produce power at night, wind turbines go still when the air doesn't move, and the grid doesn't care about your schedule. The missing piece has always been storage. How do you hold onto energy when you don't need it, and release it exactly when you do? For decades, the answer was lithium-ion. Expensive, hard to recycle, and not designed for long-duration storage. But we are seeing more unique and interesting alternative answers to this, and one that's been under our feet the entire time is the sand battery. A large insulated steel silo filled with tons of sand heated to temperatures above 600 degrees Celsius. No lithium, no cobalt, no rare earth elements, just sand, heat, and some very clever engineering. And it has just survived one of Finland's harshest winters, heating an entire town without burning a single drop of oil. So how did this idea come about? Which companies are building it? And is sand battery a serious solution to the renewable energy storage problem, or just a very hot gimmick? Let's start with the basics. A sand battery is not a battery in the traditional sense. It's a thermal energy storage system. Instead of storing electrons, it stores heat. When electricity is cheap and abundant, typically during peak wind or solar hours, that electricity is used to heat air through a resistive element, like a giant industrial hairdryer. That hot air circulates through the sand, transferring heat into the material. The sand holds onto that heat for days, sometimes weeks. So why sand specifically? It comes down to specific heat capacity. Sand can absorb enormous amounts of thermal energy without changing its physical properties. Water boils at 100 degrees Celsius, sand doesn't boil. Push it to 500 or 600 degrees Celsius and it just holds it. When heat is needed, for district heating, industrial purposes, or even electricity generation, the stored heat is drawn back through a heat exchanger and delivered on demand. Round trip efficiency 80 to 90%. Lithium-ion operates at 85 to 90%, but at a fraction of the storage duration and at a far higher cost per kilowatt hour. Sand is not the only material in this space. Thermal energy storage has exploded into a global race, and several companies are leading the charge. In Hamburg, Germany, Siemens Gamesa built electric thermal energy storage systems known as ETES. It uses volcanic rock heated to around 750 degrees Celsius. The Hamburg facility stores up to 130 megawatt hours of thermal energy. In California, a startup called Antora Energy is superheating carbon blocks to around 1800 degrees Celsius, generating both heat and electricity from stored thermal energy. Australia's 1414 degrees stores energy in liquid silicon heated to its melting point. Silicon holds roughly 10 times more energy per unit weight than sand, but the engineering complexity is significantly higher. What all of these systems share? They target the long duration storage market, the gap that lithium-ion simply cannot fill. Lithium-ion becomes uneconomical at around 4 to 8 hours of storage. Thermal systems can hold energy for days. Some projects are targeting seasonal storage, absorbing summer solar and releasing it through winter, and the cost advantage is significant. A sand battery system can cost as little as $10 to $50 per kilowatt hour of capacity. Lithium-ion sits at roughly $100 to $200 per kilowatt hour. But of all of these companies, one has arguably moved the fastest from idea to commercial reality. Polar Night Energy was founded in Finland in 2021. The company was born from a simple observation. Finland is cold and Finland is dark for months on end. Because of this, Finland desperately needs heat without burning fossil fuels. Their first commercial installation went live in 2022. This was an 8 megawatt hour system, the world's first commercial sand battery. But they didn't stop there. In 2024, Polar Night Energy commissioned a far larger installation in Pornainen, a small town of around 5,000 people in southern Finland. This is the world's largest sand battery. It stores 100 megawatt hours of thermal energy, enough to power the district heating network for an entire town. Inside the silo, 2,000 tons of crushed soapstone. Not regular beach sand, but thermally stable rock with exceptional heat retention properties. This is heated between 500 and 600 degrees Celsius. The system uses a patented closed-loop air circulation design. When electricity is cheap, often from Finland's growing wind capacity, the battery charges. When the town needs heat, it discharges through the district heating network. And then came the real test, one of Finland's harshest winters in recent memory. The sand battery held up without a single failure. It delivered 100% oil reduction for the local heating network, a 70% cut in CO2 emissions, and 60% less wood chip combustion. Polar Night Energy now has 5 operational projects across Finland, with 9 million euros in total funding, and international expansion on the horizon. So, is this actually the future of energy storage, or is the sand battery a niche solution being oversold? Let's be clear about what sand batteries genuinely do well. Cost. Sand costs almost nothing. A steel silo, insulation, a heating element, and pipes. No exotic materials, no conflict zone mining, no complex chemistry to maintain. Longevity? Lithium-ion batteries degrade after about 10 to 15 years, and sand battery has no such limitation. The storage medium can last 50 years or more. Safety. No flammable chemicals, no thermal runaway, no toxic waste stream at the end of life. Sand is sand. Scalability. A large silo means more storage. No fundamentally different technology needed, just more sand. But there are real limitations, and they matter. Sand batteries, in their current commercial form, produce heat, not electricity. That makes them perfect for district heating, industrial processes, and cold climate countries, but they are not direct replacements for lithium-ion in powering devices, vehicles, or consumer electronics. Converting stored heat back into electricity through steam turbines comes with efficiency losses of around 30 to 40%. The economics only stack up when the end use is heat itself. Geography also matters. Sand batteries make perfect sense in Finland, other Scandinavian countries, or Northern Europe. In warm climates without heat networks, the case is far weaker. Here's the bigger picture. The world needs a portfolio of storage solutions, not one silver bullet. Lithium-ion handles short-duration, high-cycling applications. Hydrogen handles long-distance transport. And thermal storage sand rock soapstone handles the long-duration heat problem in a way nothing else can match on price and simplicity. For a country like Finland, a sand battery isn't just promising, it's already delivering. 100 megawatt hours, 2,000 tons of soapstone, an entire town heated through a brutal Finnish winter without burning a single drop of oil. The most advanced energy storage technology on Earth might just be something you find under your feet.